Hey, what are you doing?
I am calibrating this electric car so I know which power setting goes with which speed. I measure the speed and power and then put a mark on the graph as follows.
That looks great. But what if you want an intermediate speed, not represented by your crosses? For example, 45 kilometers per hour.
That's easy. I can interpolate by drawing a line between all my crosses and infer the required power setting from that.
Ah, I see. So for 45 kilometers per hour, you need to use 5 watts. Why don't we give that a go?
Why is this system not working anymore?
I think you need a little more power to deal with the hill. I guess your graph was not calibrated for hills.
But how do I know how much extra power? This will keep changing depending on the magnitude of the slope.
I think we need a better approach that measures the actual speed and then adjusts the power automatically.
You're right. I will need to ponder this one.
Have you thought of something?
Yes, I'm going to measure the speed error continuously and make the power depend upon that. Big errors mean big power.
That sounds like a good idea. Can I try it with you?
Okay, I'm going to use a formula so that the power is 100 times greater than the error. Let's go.
I like the initial acceleration, but then the power seems to be dropping and we seem to be going too slowly.
Don't worry, maybe my formula is wrong and I just need a little more oomph. Let's try power at 500 times greater than the error.
Wow, that was a speedy start, but you're still not going to be too happy with this because look, you still have that error.
Oh, that error is piddly. Let's try this hill.
Oh dear, the error has gone up again and we're still too slow. Do you want some help with thinking about this?
Yes, please. I need this to work or I will never be able to sell my cars.
I've worked it out. With your formula, power equals K times error. If the error goes to 0, then the power goes to 0, so it can never work.
Of course, clever you. So what then?
I think we need to use relative power. Keep the power we already have and then add to it if there's still an error.
I see. So increase the power if we still have an error. Good idea. But how much?
Let's try something like P equals P plus K times error, say every 1 second.
Well, it seems to be working, but the acceleration is very, very slow. We took an age getting going.
You're right, but look, at least it's managing hills correctly now and giving the correct speed.
That's true, but no one will want my cars with that performance. Obviously, I need to learn more about feedback design.
I think there are loads of applications using feedback, so perhaps we can find out how they do it and learn from them.
Good idea.